You ever have one of those ideas that's so out there, so nuts that you just have to try it? Well, today we're talking about a group of creators who did exactly that. They looked at one of the most powerful and complex pieces of engineering out there, a jet engine, and thought, yeah, we can probably build one of those. So let's jump right into the moment this completely insane idea was born. And yeah, that's pretty much how it went down. Seriously. No big boardroom meeting, no complex schematics drawn up over months, just a simple, kind of crazy, yeah, let's do it. They were actually going to build a jet engine from scratch in their workshop. The ambition was through the roof, and, the potential for things to go wrong, oh, even higher. Okay, so where do you even start with a project like this? Well, you start with the simplest version you can think of. They weren't trying to build an engine for a passenger jet here. Nope. Their goal was to make a pulse jet engine. Let's dig into the basic science they were trying to wrestle with. At its heart, the concept is pretty straightforward. A pulse jet is just a series of controlled explosions happening over and over and over again, super fast. You pull in some air, you mix in some fuel, you light it with a spark, and boom, the explosion shoves everything out the back, pushing you forward. It is incredibly loud, incredibly violent, and it was the whole theory behind their entire build. So this was their first real blueprint. You can see all the basic parts are there. You've got your big combustion chamber for the boom, a way to get fuel in there, a spark plug to kick things off. But just look at that last point on the list. They knew exactly what they were getting into. One of them literally said, dude, this could actually explode. And you know what? He wasn't wrong. All right, this is where the theory gets a good hard slap from reality. Because as anyone who's ever built anything knows, what looks great on paper doesn't always work when you add things like, fire and intense pressure. Thankfully, they had a moment of common sense before firing up that giant metal tube. They decided to build a little one first, a mini prototype, just to see if their whole idea even worked. It's a classic move. Start small, fail small, and learn what you need to know without blowing up the whole workshop. And the test, well, let's call it a learning experience. For about 3 glorious seconds, it worked. It was sputtering and coughing, but it was a real, live pulse jet. But then, that intense heat just completely melted the tape they were using to hold it all together. So the big takeaway, the physics works. The materials, not so much. So this leads to a pretty obvious and kind of scary question, right? If a tiny engine running for just a few seconds can completely melt tape, what in the world is going to happen when they fire up its much, much bigger brother? And the answer, funny enough, was not much. Well, not nothing. The big engine wouldn't start. It wouldn't pulse. It made zero thrust. What it did do was get really, really terrifyingly hot. Like so hot that water would instantly turn to steam on the casing. This wasn't just a simple mistake. This meant the whole design was fundamentally flawed. So with one melted mini-engine and one giant, superheated paperweight, it was time to rethink the whole thing. And this is the part of the story where they go from just trying stuff to having a real breakthrough, a genuine aha moment that led to a totally new design. And there it is. That's where they figured it out. The problem wasn't the fuel or the spark, it was the shape. A pulse jet needs a specific shape to create something called resonance. It's like a perfectly timed echo of pressure that keeps the explosions going. Their first design was just a big tube. It had no tuning, no resonance, nothing. You can see the total change in philosophy right here. The old design was heavy, inefficient, and just plain wrong. The new one, it's lighter, but more importantly, look at that shape. It's totally redesigned to help the airflow and create those pressure pulses they need. This was their second shot, and they were hoping it would be the one. Okay, so new engine, new test. This time, it wasn't just about getting it to make a pop. It was about seeing if their new design could actually control the insane physics at play and create some real, stable power. It was time to try and tame the beast. So their startup procedure was, let's just say, not very high-tech. I mean, look at this. They literally used a leaf blower to shove the first bit of air and fuel into the engine. Then they'd hit the spark and, well, step 4 really says it all. The plan was basically light the fuse and get away. The first couple of tries, nothing. Just a little poof of flame and then silence. They fiddled with the fuel, adjusted the air from the blower, and tried again. And then it happened. It wasn't a sputter. It was a deep, earth-shaking roar. The engine didn't just start, It absolutely roared to life and kept going all on its own. They had done it. And the power was just unbelievable. The noise and the force were so strong that, according to them, the entire workshop building started to vibrate. This wasn't a science experiment anymore. They had built a genuinely powerful and, frankly, pretty dangerous machine. But of course, just when you think you've won, you find a new problem. In the middle of all the celebration, they realized the sheer force of the combustion had burned a hole clean through the steel casing of the engine. Even in its moment of success, the machine was actively trying to destroy itself. So what do you do when you have a working jet engine that's also trying to melt itself into a puddle? Well, obviously, you patch the hole and then you push it even harder. The final test wasn't about if it would work, it was about finding its absolute breaking point limit. So for the grand finale, they bolted this monster onto a big, heavy-duty trolley. This way, they could see the power in action and get a feel for how much thrust it was actually making. They locked the wheels down, braced for the worst, and got ready for one last, full-power burn. And the power was just massive. Even with the trolley's wheels completely locked, the engine was straining against its mounts, trying to tear itself free. They'd gone from a hunk of metal that wouldn't start to something that was genuinely, frighteningly powerful. As they gave it more and more fuel, the whole engine just started to glow. At first, it was this dull cherry red, but then it got brighter and brighter until the entire thing was radiating this brilliant, angry orange. It was running right at its absolute limit. And then it went past the limit. The steel just couldn't take the heat anymore. You could see it happening. The engine started to deform, to sag. It was literally melting in several spots while still running at full blast. Now, seeing that, you might think, well, they failed. It broke. But that's not the right way to look at it. This wasn't a failure. This was the ultimate success. They wanted to build a powerful jet engine, and they built one so powerful that it destroyed itself. That spectacular meltdown was the ultimate proof that their design worked. So that's where we leave it. They actually did it. They built a working, incredibly powerful, and now semi-molten jet engine. Which leaves us with the exact same wonderful question the creators asked at the end. Now that you have it, what on earth do you mount it on?